It is regarded as the deadliest predator of the Second World War, a pinnacle of engineering before which the Allies supposedly trembled in pure terror. Yet the truth hidden behind this gleaming facade is a chronicle of incompetence, bureaucratic delusion, and design flaws so fatal that they posed a greater danger to their own soldiers than to the enemy. Of what use is a cannon capable of annihilating any opponent at a distance of 2 kilometers if the vehicle carrying it must be detonated by its own crew simply because a single gear disintegrated under the weight of its own steel armour? We reveal the dark secret of a miracle weapon, so catastrophically designed that for a routine repair it had to be literally cut into 2 pieces, a true nightmare for any mechanic in the field. Why did their own tanks open fire on this comrade in arms during its first encounter? And why was this technological jewel actually a gigantic grave for resources that, far from stopping the collapse, only accelerated it? Forget the myth of the invincible steel monster. This is the dossier on one of the most useless and overrated failed designs in military history, whose greatest enemy was not a foreign army but its own gearbox. In the year 1942, self-propelled artillery was undergoing a profound and painful metamorphosis, as it suddenly became evident that existing armoured vehicles were no longer sufficient to neutralise heavy enemy units, while improvised solutions, such as open-topped mounts on Panzer IV chassis, proved insufficiently protected and possessed dangerously high silhouettes. The clamour for a specialised tank destroyer on a modern chassis grew louder, but instead of proceeding pragmatically by utilising an available hull, a bureaucratic turf war erupted between the Krupp and Daimler-Benz conglomerates, devouring precious time. In retrospect, the decision to temporarily orient the project toward the Panther II chassis, a vehicle that did not yet even exist and whose development was later frozen, seems particularly absurd, forcing engineers to waste months on useless theoretical redesigns. When they finally returned to the original Panther chassis, a vehicle was born that on paper looked like the ultimate hunter. An extremely low silhouette, thick frontal armour of 80mm sloped at 55 degrees, and the fearsome 88mm PaK-43 gun, theoretically capable of neutralising any known target at a distance of 2 kilometers. However, behind the imposing facade of this construction, hailed as a miracle weapon, lay a terrifying logistical nightmare from its very inception, one that engineers, in their blind pursuit of ballistic perfection, simply ignored. The heart of this machine, the 71 caliber length cannon, imparted a muzzle velocity of 1,000 meters per second to the projectile and could still penetrate 132mm of armoured steel at a distance of 2 kilometers, making the Jagdpanther superior to almost any opponent as long as it kept them at arm's length. Yet, the integration of this massive gun into a closed superstructure led to extreme front heaviness, which excessively stressed the forward road wheels and final drives, dramatically increasing the wear on the suspension. Even more serious was the virtually non-existent serviceability. To access the failure-prone transmission, it was necessary to laboriously pull the entire weapon system weighing over 2 tons through the gun mantlet, a process that was nearly impossible in the field under fire and drove repair crews to despair. Furthermore, the internal space for the 5-man crew was so cramped that the loader had to perform the labour of a galley slave to heave the heavy shells from poorly positioned racks into the breach, while the radio operator in his corner was practically blind because the design omitted dedicated observation slits for him. These ergonomic catastrophes were nonetheless ignored by leadership in the belief that superior firepower would compensate for all mechanical deficiencies, a conviction that would soon prove to be a fatal mistake. The centrepiece of this technical hubris was undoubtedly the primary armament, the 88mm PaK-43/3, a weapon whose performance eclipsed almost everything prowling the battlefields of that era. With a barrel length exceeding 6 meters and a weight of more than 2,000 kilograms, this masterpiece of artillery was capable of firing armour-piercing shells at such a dizzying muzzle velocity that they punched through the frontal armour of nearly all Allied vehicles at distances where the enemy could barely visually identify the low silhouette of the tank destroyer. To harness this ballistic superiority, engineers installed highly complex aiming optics, such as the WZF-1/4 telescopic sight with 10 times magnification, which theoretically allowed the gunner to pinpoint enemy units at up to 4 kilometers away, a theoretical capability that, in the rugged reality of the Western Front, often collapsed due to the lack of a clear line of sight. This discrepancy between technical feasibility and tactical reality ran like a red thread through the entire design. They built a precision surgical instrument for long-range duels, but imprisoned it within a vehicle that, lacking a rotating turret, forced the driver to pivot the entire 47-ton colossus via sensitive track steering for even the coarsest aiming correction. Beneath the massive frontal plate sloped at 55 degrees to provide excellent protection, while simultaneously turning the interior into a furnace, laboured the 12-cylinder Maybach HL 230 P30 gasoline engine. This power plant, delivering a nominal 700 horsepower from a 23-litre displacement, was a technical monster that devoured immense quantities of fuel and frequently reached its thermal limits in rough terrain. The power transmission was handled by the AK 7400 semi-automatic gearbox from the Zahnradfabrik Friedrichshafen company, an engineering marvel that was, however, not dimensioned for the torsional stresses of such an unbalanced, nose-heavy vehicle. The constant necessity to pivot the entire machine for even minimal firing adjustments brutalised the final drives and the braking system far beyond the planned tolerances, turning the Jagdpanther into a giant with feet of clay. Added to this was the absurd arrangement of the driver's vision aids. While early models featured 2 periscopes, one was later simply omitted and the hole welded shut, leaving the driver practically blind on the left side and degrading manoeuvres in tight combat zones to a dangerous game of chance. The interior itself resembled a torture chamber more than a workspace. The ammunition storage was designed such that while 60 shells were theoretically available, in practice they were often blocked by other pieces of equipment, which drastically reduced the rate of fire. The development of close defence measures seemed particularly grotesque. Initially, there were pistol ports in the armour through which the crew was supposed to fire submachine guns, a concept from the First World War that was utterly out of place in a modern tank destroyer. These were later replaced by a machine gun 34 in a bull mount to the right of the cannon, but here too the planner's lack of foresight was evident. The traverse range was minimal, and the radio operator tasked with operating it had to wedge himself into a contorted posture between the transmission block and the radio set. Furthermore, the enormous length of the gun barrel meant that when driving through uneven terrain or wooded areas, it ran the risk of digging into the ground or snagging on trees. Consequently, the barrel had to be locked in a special travel crutch on the hull front during every march, a procedure that cost precious seconds in the heat of battle. While the designers were still debating details such as the introduction of a 2-piece barrel to save raw materials, a storm was already gathering over the production facilities that would render all these technical subtleties irrelevant. Serial production was originally supposed to start in January 1944 at the MIAG plant in Braunschweig, an enterprise already completely saturated with the production of assault guns. The notion that one could simultaneously launch mass production of a completely new, highly complex vehicle evidenced a disconnect from reality that was endemic within the German armament leadership. The plans called for gargantuan output numbers, but no one had calculated that the Allies had long since set their sights on the industrial centres. By the time the first 5 chassis were laboriously assembled, the bomber squadrons were already on their way to smother the dream of the miracle weapon in a hail of high explosive bombs before it could truly begin. The reality of manufacturing swiftly devolved into an industrial grotesque, as the Allied air forces identified the Mühlenbau und Industrieaktiengesellschaft, or MIAG, plant in Braunschweig as a primary target, systematically bombing it more than 10 times throughout 1944 and regularly reducing the production lines to heaps of smouldering rubble. These constant interruptions meant that the optimistic projections of the Army Weapons Office, which envisioned a monthly output of up to 150 vehicles, withered into pure bureaucratic fantasy. Actual delivery numbers in some months barely left the single digits, constituting a genuine military joke. In a desperate attempt to salvage production, the M&H firm in Hanover and later the Maschinen- und Fabrikbärenbedarf in Berlin were brought in as additional manufacturers, but this frantic decentralization maneuver only intensified the logistical chaos, as components now had to be transported across an already shattered transport network, and the compatibility of parts was often a matter of chance. While the assembly lines stalled repeatedly, and raw materials such as high-grade steel and rubber became prized rarities, engineers tried feverishly to adapt the design to the dwindling resources, leading to a confusing variety of sub-variants that even the repair crews could hardly distinguish. causing the logistics of spare parts to collapse. Thus, the so-called Ausführung G1 was born, which, contrary to its misleading designation, was not based on the modern Panther G chassis, but still utilised the older Ausführung A frame, while simultaneously having components of the newer version installed. A true technical chimera. These hybrid vehicles were eventually equipped with modified exhaust systems featuring sheet metal shrouds to hide the betraying glow of the pipes at night, as well as redesigned maintenance hatches on the engine deck, but these cosmetic interventions could not fix the fundamental structural problems of chronic overloading. Symptomatic of the total lack of direction was the late introduction of the Ausführung G2, which finally used the reinforced Panther G chassis, but appeared only in the final months of the war and in numbers far too paltry to achieve any strategic effect or compensate for the massive losses. Manufacturing quality plummeted in parallel as skilled workers were increasingly drafted to the front and replaced by inexperienced forced labourers whose silent acts of sabotage or simple ignorance led to cracked welds, leaking seals, and engines that overheated at the very first startup. In the bomb-blasted hangars, unfinished hulls piled up, missing optical devices or transmission components, while the bureaucratic leadership in Berlin continued to shuffle paper armies and demand delivery dates that were physically impossible to meet. When enough vehicles were finally scraped together in the early summer of 1944 to equip the 65 4th Heavy Tank Destroyer Battalion as the first unit to be theoretically complete, it resembled less a military strengthening and more an experiment on a living subject with a fatal outcome. This elite unit, dispatched to the invasion front in Normandy, reported catastrophic breakdowns after the very first kilometres of the march. Not from enemy fire, but because the over-engineered final drives literally crumbled under the vehicle's own weight before a single enemy tank was even in sight. When the few operational examples of the 65 4th Battalion finally reached the front lines in Normandy, what followed was not a triumphant debut, but a shameful farce that perfectly illustrated the incoherence of the entire programme. The vehicle's silhouette was so novel and so unfamiliar to the German troops themselves that a crew from a Panzer IV of the 2nd Armoured Division mistook their own ally for an enemy breakthrough and opened fire. Thus, the first losses of this top-secret weapon were not caused by Allied action, but by friendly shells. It was not until late July 1944 that the weapon system could briefly demonstrate its theoretical potential, when a group of 11 British Churchill tanks from the 6th Guards Armoured Brigade fell into an ambush at Les Loges. In a matter of minutes, they were neutralised by the surgical firepower of the 88mm cannon, without the British gunners ever managing to locate their attacker. However, this tactical success remained an absolute exception, as the reality of the battlefield showed that for every enemy tank destroyed, several Jagdpanthers were knocked out by broken final drives or overheating engines. The delicate technology simply could not withstand the punishment of constant position changes in the impassable terrain of the Norman bocage, and the repair companies collapsed under the weight of the breakdowns. The operational command also committed the fatal error of employing these turretless casemate machines as if they were regular battle tanks for dynamic counterattacks, a role for which they were totally unsuitable due to their vulnerable flanks and limited peripheral vision, making them easy prey for the more agile Shermans. At the same time, in the autumn of 1944, they lost their aura of invincibility when American forces deployed the GMC M36 Jackson, whose powerful 90mm gun could pierce the frontal armour of the Jagdpanther, previously considered impenetrable, even at normal combat distances, while at least small groups operated on the Western Front. The deployment on the Eastern Front resembled a Deresare homeopathic dose. In January 1945, only a tiny handful of these vehicles faced the gigantic Soviet armoured armies, where they were often absurdly sacrificed in infantry support tasks. Against the heavy Joseph Stalin class, or the overwhelming mass of the T-34s, the use of isolated Jagdpanthers appeared almost touchingly naive, especially when the constant retreat battles allowed no time for the complicated recovery of damaged vehicles. Consequently, dozens of these high-tech machines were simply sabotaged by their own crews on the roadsides as soon as fuel ran out or the most insignificant mechanical component failed. In this way, the units originally conceived as specialised hunters degenerated in the final phase of the conflict into a sort of mobile fire brigade, desperately trying to plug gaps in a front that no longer had any possible closure. Despite isolated reports of impressive enemy kill counts, This changed nothing about the strategic uselessness of a weapon system that statistically required more maintenance hours than it spent minutes in combat, and whose crews often fought more intensely against the traps of their own mechanics than against the actual enemy. When the war ended, it was not enemy shells that stopped the majority of the Jagdpanthers, but the mundane lack of gasoline and spare parts. This raised the fundamental question of whether this technical jewel was truly a miracle weapon, or just a gigantic waste of resources that only delayed an inevitable collapse by a few minutes. Yet even when the cannons fell silent, the design continued to fuel heated debates among the victors, who sought to determine whether this vehicle represented a misunderstood masterpiece or a military dead end of monumental proportions. A sober analysis of performance parameters in direct comparison with international competition reveals that the reputation of this machine as supposedly the best tank destroyer of the entire conflict hardly withstands critical scrutiny, as it relies primarily on isolated duel situations that completely ignore the broader strategic context. While the German model is frequently measured against the Soviet Su-100 or Su-85, its true functional counterpart was the heavy ISU-122, and it is in this comparison that the conceptual narrowness of the German design becomes painfully clear. Although the 88mm cannon possessed excellent penetration against armoured steel, its destructive blast effect against infantry, fortifications or anti-tank positions was nearly negligible compared to the massive power of the Soviet rival's 122mm howitzer. The opponent bet on universal demolition hammers capable of tearing turrets off hulls through sheer kinetic energy and crushing concrete bunkers, while the German armament industry manufactured a high-precision scalpel that increasingly lost its relevance in a war of attrition where quantity and versatility were the decisive factors. Post-war investigations by Allied experts, who subjected captured examples to exhaustive testing, confirmed the image of a technically brilliant but logistically flawed construction that might have excelled in peacetime operations but represented pure agony under field conditions. Particularly the French armed forces, which utilised refurbished Jagdpanthers for some time after the conflict, reached the sobering conclusion that the maintenance effort bore no reasonable proportion to the military utility. The complicated interleaved road wheel system, which ensured a smooth ride, clogged immediately with mud and snow, turning the replacement of a single inner road wheel into an operation lasting several hours, during which half the suspension had to be dismantled, a luxury problem that no army dependent on rapid mobility can afford. British engineers, who still assembled a few vehicles from remaining parts in Hanover for testing purposes, noted with astonishment how much precise expert labour was required just to correctly adjust the final drives, explaining why mass production could never function efficiently. Ultimately, the fact remains that the resources devoured by these approximately 400 units of high-tech equipment would have been far more sensibly invested from a military standpoint in the production of simpler and more reliable weapon systems. The concentration on such a miracle weapon deprived the manufacturing of standard tanks of valuable capacities, of high-quality steel, rare alloys, and specialised workers, without the tiny number of units at the front being able to even remotely fill the gaps that this drain of resources caused. It is an irony of industrial history that the very technical perfection of the aiming optics and the ballistic superiority of the cannon contributed to obscuring the essential fact. A weapon system that cannot reliably move from point A to point B is military worthless, regardless of how accurately it theoretically fires. The Jagdpanther thus stands in history not as a triumph of engineering genius, but as a metallic symbol of a completely disconnected perception of reality, where strategic inferiority was to be compensated for by increasingly complex, expensive, and sensitive machines that in the end often merely stood motionless in the landscape as steel monuments to futility, because the engine failed or the fuel ran out, while the simple but functioning mass armies of the adversaries simply drove past them toward the definitive end of the war.